opened the Engineer's Grimoire, a field manual for banishing circuit gremlins and keeping the magic smoke where it belongs, forged in solder and bound by mystery. Once whispered about in dimly lit workshops and passed between those who dared to build beyond the veil, this is your handbook for surviving the technical unknown. I'm Rachel De Barros, your guide, witch of the workbench, and keeper of the grimoire. Each episode, we turn a new page to explore the tools, wiring, and code you'll need to bring your Arduino-powered creations to life and keep them from turning into cursed artifacts. This is engineering with a touch of the arcane. Before we begin today's ritual, or lesson, just a reminder, you can find all the wiring diagrams, pinouts, code, and extra tools from this episode over at racheldebarros.com. Go check it out after this episode. It's like finding the digital Necronomicon, but instead of summoning demons, you summon working circuits. Today's episode is called The Power Crystal, because before you can awaken your electronics, you need to breathe life into them. And whether you're building a haunted portrait, an EMF scanner, or just trying to make an LED blink for the first time, the question always comes up. How do I power this thing without blowing it up or draining the batteries before the ghosts even show up? Let's break it all down, starting with the two main energy sources in our world. Batteries, the portable potions. Batteries are like elixirs in your circuit craft. Pop the cap and your project comes to life, temporarily. They're portable, self-contained, and perfect when your build needs to roam untethered from the mortal grid. Here's what's in my battery potion cabinet. 9-volt batteries. They're easy to find, quick to use, but don't last long, like a burst of energy in a bottle. Useful in a pinch with just enough juice to complete a short task before fizzling out. AA batteries, the multi-dose stamina potion of the hobby world. Use 4 in series for 6 volts and you've got yourself a reliable source for sensors, lights, servos, or small motors. 18650 lithium-ion batteries. Now we're talking high-tier alchemy. These rechargeable vials pack serious capacity. Each one provides around 3.7 volts. Combine 2 in series for 7.4 volts, or 3 for 11.1 volts. Perfect for feeding Arduinos through the VIN pin or barrel jack, and they're rechargeable, which makes them great for high-use builds. LiPo, or lithium polymer batteries. These are like glass vials of raw energy, lightweight, compact, and powerful. Used in drones, RC cars, and custom props. But take heed, LiPos can be volatile if punctured, overcharged, or shorted. This is unstable magic we're dealing with. Always charge with a proper LiPo charger. Store in a fireproof bag and never leave them charging unattended, unless you want to summon the fire department. Now, when choosing your battery elixir, you want to consider 2 key properties. One is voltage. Is it enough to satisfy your project's thirst for power? But don't go overboard. Too much and you'll either fry components instantly or dramatically shorten their lifespan, like a candle burning twice as bright, but half as long. And keep in mind, as your battery depletes, its voltage drops too. This voltage sag can cause resets or strange behavior before the battery is technically dead. The other is current capacity. How long can it keep casting before it needs a recharge? Certain battery types, like the 18650 lithium-ion cells and LiPos, come in a range of capacities, measured in milliamp hours. I always recommend choosing a battery with a higher capacity rating than you think you'll need, because nothing's worse than your project flatlining mid-battle. And one last warning from the shadows. If your project includes motors, solenoids, or anything power hungry, don't give it a weak brew. An underpowered battery can leave your circuit glitchy, unstable, or rebooting when it shouldn't, like a cursed amulet with a dead crystal inside. Wall adapters, tapping the eternal grid. Or as we affectionately call them, wall warts, those chunky little bricks that hang off your power strip like forgotten relics. Ugly? Yes, but they're powerful, and sometimes that's all that matters. Wall adapters tap directly into your outlet's AC power and converts it into the DC voltage your circuit craves. They're perfect for projects that live in one place. Think animatronic tombstones, flickering hallway motion sensors, or a prop that haunts your living room window every Halloween. Wall adapters are also a great option for higher power builds, or when you don't want the hassle or the cost of constantly replacing batteries, especially for anything with motors, servos, or LED strips that sip current like a thirsty poltergeist. So, how do you choose the right wall wart from your drawer of mismatched adapters? Here are the 3 sacred criteria. Voltage output. You want a wall adapter that outputs a voltage compatible not just with your microcontroller, but every component in your circuit. For popular Arduinos like the Uno, Nano, and Mega, 7 to 12 volts DC is the sweet spot when you're powering through the barrel jack or V-in pin. Too low, and the onboard voltage regulator can't do its job. You'll get brownouts or boot failures. Too high, and your onboard regulator will run hot, wasting the excess energy as heat. I'm talking finger-sizzling, ghost conjuring levels of heat. But remember, your Arduino isn't the only thing in the circuit. You might also have LEDs, servos, sensors, motor drivers, or audio boards, and they all have their own voltage requirements. If your adapter is putting out more voltage than some components can handle, you're going to need a way to tame that excess energy. But don't worry, we'll exercise that demon in the next chapter. Then there's current rating. Every wall wart has a maximum output current, usually in milliamps or amps. Make sure your adapter can supply at least as much current as your project needs. Good news, your circuit will only draw what it needs, so it's totally safe, encouraged even, to use a higher current adapter. Got a prop that needs 9 volts and 800 milliamps? Use a 9 volt 2 amp adapter with no fear. The adapter won't push current, it just makes it available. And here's another reason I like choosing an adapter that's rated a little higher than I think I'll need. It runs cooler. When you push a wall adapter close to its current limit, it starts to run warm, and over time, that heat can shorten its lifespan. A cooler adapter is a happier adapter and less likely to ghost your project halfway through a performance. And finally, plug polarity. This one's a classic beginner trap. Most Arduino-compatible wall adapters use a barrel plug with center positive polarity, meaning the center pin is positive and the outer sleeve is ground. But not all adapters or all components follow that rule. Always check the little polarity symbol on the label. It looks like a circle with a plus sign touching the center of the pin and a minus sign touching the barrel. If your board doesn't have reverse polarity protection, plug in the wrong one and your board might release its magic smoke permanently. So when it comes to powering your stationary builds, wall warts are the dependable familiars of your electronics coven. They may not be glamorous, but they show up when it counts. And never ask for AA batteries at the worst possible moment. Voltage regulators. The energy transmutation right. Let's face it, most circuits you build won't be simple one-trick spells. You're not just powering an Arduino and calling it a day. You've got components, plural, and they rarely play by the same voltage rules. Here's what I mean. A wiper motor, which is perfect for gates, pop-up props, doors, might want 12 volts. Addressable LEDs like the WS2812B strips, they demand a clean 5 volts. Sound modules, sensors, RF receivers, usually 3.3 or 5 volts as well. And most servos, they're happiest around 6 volts. Now, choosing a power supply with enough current, that's the easy part. You can overestimate the current all day long. If your circuit only pulls 1.5 amps from a 5 amp power supply, no problem. But voltage? Voltage is finicky. It has to be just right for each component. Too low, and your prop stutters. Too high, and you might as well hold a seance for your fried microcontroller. So what do? You're not going to plug in 3 different power supplies just to match each voltage rating. That's how you summon chaos, not a working project. This is where voltage regulators come in. These mystical voltage transmutation devices allow you to feed in a higher voltage, then step it down just enough for the more sensitive parts of your circuit. Now let's talk about the 2 main types of voltage regulators you'll use in your own projects. The first is linear regulators. These are the old school mages of clean voltage. You feed them a higher voltage, say 12 volts, and they output a stable 5 volts. The excess? It's burned off as heat, like casting a containment spell by sheer resistance. They're simple, cheap, and come in preset voltage outputs. That means you'll need to buy the specific one that matches the output voltage you want. A 7805 gives you 5 volts. A 7809 gives you 9 volts. A 7812 gives you guessed it, 12 volts. No adjustments, no dials, just fixed output right out of the box. But here's where things get warm and weird. Let's do some spooky math. You input 12 volts and output 5 volts. That's 7 volts lost as heat every second your circuit is running. But it's not just how long your circuit runs, it's about the size of the voltage drop. The greater the difference between your input and output voltages, the hotter that regulator is gonna run. And when you pile a long runtime on top of a big voltage drop, you've got yourself a little heat demon on your hands. So yes, if you're powering motors, servos, or other current-hungry components, your regulator may get hot enough to cook a cursed marshmallow, maybe even summon a faint whiff of toasted regret. So let's look at switching regulators, also known as buck converters. These are the modern-day alchemists of voltage control. Instead of burning off the excess, they convert it with magical efficiency using high-frequency switching. You can take a 12 volt and drop it to a 5 volt with almost no heat loss. They're compact, powerful, and adjustable with a tiny screwdriver. Some even come with digital displays, so you can dial in the voltage precisely without having to use a multimeter. Here's my go-to strategy when working with circuits that include components with different voltage needs. I start by identifying the component that requires the highest voltage. That becomes my main power supply, the source from which all others descend. It could be a 12-volt wall adapter, a 3-cell battery pack, or even a lithium-ion source. Whatever the power source is, it should be able to handle the full current load and deliver that top-level voltage. From there, I branch off, using buck converters or regulators to step down the voltage to meet the needs of everything else. If multiple components require the same voltage, say a servo and an audio board both need 5 volts, great! They can share the same buck converter output, like drawing from the same enchanted well. That's one power source, multiple voltage levels, and a clean, manageable circuit that doesn't look like it was assembled during a thunderstorm. One final ritual: always test your voltage output. Before you connect power to your Arduino or Fragile modules, grab your multimeter and measure the output of your regulator or buck converter one last time. Don't skip this step. Even 1 volt too high can send a component straight to the spirit realm. Your multimeter is your voltage scrying stone. Trust it. No one wants to troubleshoot a dead board during a full moon. All right, by now, you've wandered the battery crypts, communed with wall warts, and summoned voltage regulators like a seasoned circuit conjurer. But how do you know which power crystal to use? Here's how I decide. If you need portability and low power, go with batteries. They're great for motion-activated sensor props, small LED effects, robot vehicles, or field devices with limited runtime. Lightweight, flexible, and no cords to trip over in the dark. Just don't expect them to run your animatronic demon for 3 nights straight. If your project is stationary and needs to run continuously, go with a wall adapter. They're perfect for haunted house props, interactive displays, anything that lives in one spot and needs long-term uptime. Plug it in and forget it. What I keep in my power crystal cabinet. Every circuit sorcerer needs a good set of power crystals ready to deploy. And whether I'm building a prop, prototyping a sensor trap, or just experimenting on the workbench, these are the power-related items I never leave behind. A 9-volt battery clip with a barrel plug, quick to connect when I need portable power in a pinch. A couple of AA battery holders. I keep the 2, 3, and 4-pack versions on hand, just in case a project needs 3, 4.5, or 6 volts. A USB power bank. They output a clean 5 volts and are great for powering microcontrollers or recharging my gear mid-build. Wall adapters. I always carry a 5-volt 1 amp, a 9-volt 2 amp, and a 12-volt 5 amp. With these, I can power almost anything in my arsenal. Even better are the wall adapters with an adjustable voltage dial, giving you a range from about 3 volts to 12 volts in a single adapter. Buck converters. These little voltage tamers help me feed different components exactly what they need without burning through regulators. And of course, a digital multimeter to measure voltage, check polarity, and make sure I'm not about to vaporize any of my electronic minions. Oh, and let's not forget the most important tool of all, a healthy fear of reverse polarity, because when power flows through the wrong portals, that's when things really start to get haunted. So that's today's entry from Engineer's Grimoire, another revealed page from the handbook that wards off the chaos that haunts your circuits, guides your soldering hand, and teaches the practical magic behind electronics. From choosing the right battery elixir, to taming the chaos of wall adapters, to bending voltage to your will with regulators and converters, you now hold the knowledge to power your circuits safely, confidently, and maybe just a little magically. Remember, the key to survival in the technical unknown isn't luck, it's preparation. And no matter what you build, a haunted portrait, a motor-driven gate, or a cryptic sound trap, your project is only as strong as the power behind it. If you enjoyed this episode, don't forget to subscribe, rate, and share Engineer's Grimoire with your fellow builders and circuit sorcerers. You never know who else is out there, staring at the breadboard, wondering why the LED won't light. Visit RachelDeBarros.com for all the wiring diagrams, build sheets, code, and resources you need to keep building and keep surviving. Until the next time, don't trust a quiet breadboard. Something always stirs beneath the traces.